Hey folks, we're looking at class number 40. We're going to work through some angled projectile questions. So before we begin, which component of velocity affects the time of flight and the max height? Well, think about it. If I want something in the air to be, or something to be in the air for more time or less time, or higher or lower, which component of velocity is going to dictate that? The vertical component, the up and down component, or the horizontal component? So hopefully you know that the vertical component. All right. Because we know, hopefully you know this, that horizontal velocity or horizontal motion in general has no effect on time or height. Now, what factors affect horizontal range? Simply the horizontal component of velocity, and time of flight. All right, so let's look at some examples here. So a golf ball is hit, the initial velocity of 35 meters per second, an angle of 23 degrees. Find the time to apex, total time, max height, and horizontal range show all work. So when I say this little triangle below here, what I'm referring to is the initial velocity triangle, where this is 35 meters per second, and this is 23 degrees, right? So to find, we have the x component here, and we have the y component here. Now the x component is going to be 35 cos 23, and the y component is going to be 35 sine 23. So let's calculate those really quickly. 35 cos 23 is going to be 32.2. And 35 sine 23 is going to be 13.7. So let's start filling some of this in. We know in the y direction the initial velocity is going to be 13.7. The final velocity at the max height is going to be 0. The acceleration is going to be, in the y direction, negative 9.8 meters per second squared. In the x direction, we know the velocity is 32.2 meters per second, and it doesn't change. We know the acceleration in the x direction is 0. All right, so let's start finding a few things. So time to apex is going to be in the y column here. So we'll label that 1. So let's see, we don't have d, so we can use this one here. Vf equals Vi plus At. So Vf is going to be 0, Vi is 13.7, A is negative 9.8, T is our unknown. So T comes out to be 1.4 seconds. All right, so we can fill that in right here. Now, it's actually a good habit to close the solve for angled projectile questions, to close off the time portal and just show that we're going to multiply by 2 to get the time in the x direction, the total time, 2.8 seconds. Now, max height, that's in the y direction, so let's try to not use our solved value of 1.4 seconds. Let's try to use our givens. So we can use the equation Vf squared equals Vi squared plus 2Ad. Vf is 0, Vi is 13.7 squared plus 2, negative 9.8 d. And you should do some algebra here. I'm not going to show that right now. 9.6 meters. All right, so now to find the range, that's the horizontal direction. Let's see. Now, again, watch the last video, but I did describe you can use this equation d equals VIT plus 1/2 AT squared. But realize that since the acceleration is 0, this whole thing becomes 0, okay? Because A is equal to 0. So we just have d equals Vi, which is 32.2. It's the same as V final. And T is going to be the total time for the x direction because the ball goes up and comes down. And this is a little bit rounded, but you get about 90 meters. So that's how far it's going to go horizontally. So let's check out the next one here. The next question here is very similar, but quite different. So the initial velocity is still 35 meters per second, But this time the angle is 67 degrees. And notice that this is the complementary angle to the 23 degrees in the previous question. So this is going to be 35 sine of 67, which ends up being, make sure in degrees mode, it ends up being 32.2 meters per second. The same x component of the triangle before, because if you think about it, the triangle is just kind of rotated. This right here is going to be 35 cosine of 67. So this is, I think, what was it, 13.7? Yeah, it's going to be 13.7. Try those out in your calculator, though, just to make sure you're getting the right values, and just double check my work, too. So in the x direction, we know the acceleration is 0. And we know now that our velocity in the x direction is 13.7 meters per second. In the y direction, our initial velocity is going to be 32.2 meters per second, and our final velocity is going to be 0 at the apex. Our acceleration in the y direction is always negative 9.8 or 9.8 meters per second squared. Let's get going. Let's solve for the time to the apex. So we're going to do this the exact same way we did it before, except the numbers are different. VF equals VI plus AT. So VF is 0 in the y direction. VI is going to be 32.2 plus negative 9.8 T, and you should get about, again, rounded, 3.3 seconds. So let's throw that in here. So we're going to actually, again, close off the time portal for any angled projectile, multiply by 2 to get the x, the total time. All right. Now to get the max height. Max height is in the y direction. So again, we can use 3.3 to solve for it. We can do like d equals VIT plus 1/2 AT squared, but again, maybe that 3.3 is a little bit wrong. Maybe it's a little bit too rounded. So let's use our givens. VF squared equals VI squared plus 2AD. So VF is 0. VI is going to be 32.2 squared plus 2, negative 9.8 D, and D should come out to be a pretty big number, 53 meters. So take a second just to think, like, does this make sense? It's shot at the same velocity, but at a higher or steeper angle. It's in the air longer than it was last time. It's going higher than it was last time. Does that make sense? Hopefully it does. You fire something at a higher angle. All right, now the last bit we're going to do here is the horizontal range. So D equals VIT plus 1/2 AT squared. Like I said, this whole term goes away because the acceleration in the x direction is 0. So we have D equals our initial velocity is just our total velocity, 13.7 in the x direction. And our total time, 6.6. We should get 90 meters, about. Now, if we did not round at all, our ranges would be perfectly identical, 90 meters. That's an important point. Because what conclusion can you make about the range of projectiles with the same launch velocity, in this case 35 meters per second, and complementary launch angles? They have the same range. Okay, that's true for any given velocity. So if the velocity is 10 meters per second, if it's launched at 50 degrees, if it's launched at 40 degrees, that'll have the same range. So again, the initial velocity has to be the same. Then the complementary angles have the same range. But again, the initial velocity has to be the same first. Number 3 was just do a question on your own. The method is identical to the previous two, so I'm not going to show that again. Just the numbers are obviously going to be a little different. One thing I do want to talk about, though, is see, it says explain where the ball is traveling the slowest. And I'm just going to draw a brief little picture up here. So if I have a ball, it goes through the air and comes back down. It has Vx here, right? Vx doesn't change. Vx is always a constant number. Forget what the number is. It doesn't matter, but Vx is a number. And we have Vy when it's thrown up. But realize that Vy up here is equal to 0. 0. And Vy is down here. It's going down. Okay, so where is it traveling the slowest? Think about this. Look at this picture. Where is it traveling the slowest? Vx is always the same, but Vy changes. So where is it traveling the slowest? At top of flight. Why? It has only a Vx and no Vy. All right, really important idea there. All All right, a soccer ball is kicked on level ground with an initial vertical velocity of 15 meters per second. Assume the ball lands at the same height from which it is kicked. What is the total time the ball is in the air for? So they give you the initial vertical velocity here. So it's basically, to find the total time of flight, we really only need the y direction or the y column of our xy chart. So I'm actually going to kind of draw that out. Here's y direction. So we have vi, vf, a, d, t. Sorry, it's kind of crammed in there. So the initial velocity in the y direction here is 15 meters per second. The final velocity at the apex is 0. Acceleration negative 9.8 meters per second squared. D doesn't matter. Forget that. We'll just put a squiggly there, and we're looking for T. Okay, this will give us the time to apex. So if we use VF equals VI plus AT, VF is 0, VI is 15, plus negative 9.8. T is going to be our unknown, and T comes out to be, I think, 1.53 seconds. But this is not the answer. This is the time to apex. Okay, so multiply it by 2, 3.06 seconds. That is the total time. All right. Now let's look at this question down here. It says the total horizontal distance traveled by the tennis ball during the entire time of flight, or entire time the ball is in the air. Well, we're given the x and the y components of the velocity here. And we're given the time to the top. But to get the total horizontal range, you need the total time. So let's write that down first. So t total, so total time equals 0.92 seconds times 2, because it's got to go up and come back down. So that's 1.84 seconds. Now in the x direction, to get the x range, we can use the equation d equals vit plus 1/2 at squared. But remember, ax equals 0, so that whole term goes away. So d equals, our initial velocity in the x direction doesn't change, it's 9, not 90, 9 meters per second. Our time is 1.84 seconds. So we get about 16.6 meters. All right, and there we have it.